Hi guys, so we're going to go over this question here, and it's about jumping and figuring out normal force acting upon someone while they jump. So we've got Gene, he's jumping as shown, so you can see that his height at the bottom was 0.37, his height as his feet are leaving the ground is 1.05, and his height at his peak is 1.78, and these are all midsection heights. And that's what we're going to use. So technically he does have GPE at 0.1. He also has GPE at 0.3, which is what we're going to use, because here at 0.2 he has GPE plus KE, but we can't quantify that because we don't know how fast he's moving. So in order to use total energy, we're going to have to use 0.1 and 0.3 because we can calculate that. So up here we've got his weight in newtons. It's 779, so that means his mass in kilograms is 77.9, and we want to know the normal force. So what we're going to start with is E1 plus W equals E3. And again, we're using E1 and E3 because we don't know how fast he's going at 0.2, so we cannot calculate this KE part. But what we should know is that normal force only exists when his feet are touching the ground, and there's nothing here. There's no normal force at 0.3. We'll get to that point. So E1 is going to be GPE1. And since I'm using GPE, I'm only going to use the work of the normal force. I'm not going to use work of gravity. Those are the only two forces at work here. And we've got GPE3 for E3. Okay. So mgh1 plus, so the work of normal force gives us normal force times d. That's equal to mgh3, sorry. Okay, so what we've got here, I'm going to plug in. Technically, if his weight is 779, that's force of, that's force of gravity. Fg, and Fg equals mg, so I'll just plug that in. So for mgh, I'll do 779 times height 1, which is 0.37. Okay, I'm going to skip over for normal force times d. I'm going to skip over the d for a second. And over here, mgh is 779 times, let me give myself a little more room here. 779 times his height at 0.3 is 1.78. So here's the trick to this, and that's that he only has normal force between points 1 and 2. So this d here, this displacement, is only going to be the displacement, the difference between height 1 and height 2. So that's 1.05 minus 0.37, and that is going to be 0.68. So that's what I'm going to use for the D. Okay, so I'm going to do my calculations. So I've got 288.23. I've got plus the 0.68 normal force. And then the 779 times 1.78 is going to give us 1386.62. Okay, the next step is to subtract this 288. Okay, and I'm going to need a little bit more room, so I'm going to erase some of this stuff at the top. All right, so now we've got, this goes away, we've got 0.68 Fn normal force. It's equal to 1098.39. All right, and our last step is going to be to divide by 0.68. And then we'll get normal force. So normal force is equal to 1,615. It's 0.27. I'll just round it to the nearest whole number. 1,615 newtons. And that makes sense. In real life, usually people can push with twice the force of gravity, 2 to 3 times the force of gravity. His force of gravity is 779, so 2 times that is 1558, and 3 times that is 2337. So he falls somewhere in the middle, a little bit closer to 2 times gravity. We know Gene, he's like a high jumper and stuff, so he probably can, I probably didn't do the numbers right, he probably is closer to that than this, but whatever. So as long as it's somewhere in between 2 to 3 times, because that's real life, 2 to 3 times the force of gravity, then we're good. The last thing, let's see, there's one more part to this. So it asks, what force did Gene push down with? So we're thinking that when he pushed down on the ground, that added more force, and we saw that increase in normal force, because his free body diagrams would look, this is his force of gravity of 779 newtons, and then his normal force is 1615 newtons. So we know that the force that he pushes down on, the floor responds by pushing up with that same amount of force. So the difference between these two, the 1615 and the 779, is going to be how much force Gene applied to the floor. So when we do that, we get that Gene applied, it's 836 is what he applied. So we go Gene, so 1615 minus 779 is the 836. So that's how much he was able to push with the floor with, okay? So that's 2 floor. All right. Sorry this is so messy. That's what we got.